Improper integrals part 3. In this video, let's start by doing an improper integral that has infinity in both limits. When we do this, we need to start with the same technicality. In this case, I will let a go to negative infinity and then do the integral from a to some value. Now we can't just plug in infinity or the limit as b goes to infinity and put b on top. Instead, we need to break up the integral somewhere in the middle at some finite value. And you can choose whatever value you would like to choose. So I will choose something that's pretty simple, or I think will be simple to plug in. In this case, I'll choose 0. Which means we need to do another integral starting at that value that we chose, 0, and then go into b of that same integral, like such. Now we're going to find the antiderivative. Notice that this is a u sub. If I let u equal negative x squared, then du is negative 2x dx. So for both of these integrals, I need a negative 2 for my du and then negative 1/2 to fix it. I'll put it on both like that. And then I have the limit as a goes to a negative infinity of negative 1/2 from a to 0 of e to the u du. Now let's check to make sure that I can still put a goes to a negative infinity and I can still put 0 on the top. So if a goes to negative infinity, remember that's an x value, then u goes to negative infinity squared. So it's still negative infinity on the bottom. And if my upper limit, which is not a but x, if my upper limit is 0, then u goes to negative 0 squared actually equals negative 0 squared, which is 0. So my limits still work over there, and I will leave it. And then let's do the limit as b goes to infinity of negative 1/2. Now I already know I can do 0, so can I plug in infinity up top here? Can I just plug in b like this? Does that work? Okay, let's check it over here. So when b goes to infinity, remember b is really x, then I have u goes to negative infinity. So I need to fix this somehow. How about I just do it like that? We'll see if that works for us. That gives me my new u limit as negative infinity. And then we will continue on and evaluate. I get negative 1/2, and then e to the u from a to 0, plus the limit as b goes to infinity of negative 1/2 times e to the u from 0 to negative b. Now I'm going to plug in my values. I get, let's see, negative 1/2 times e to the 0 minus e to the negative infinity, which is really close to 0, plus, let's do the back part, negative 1/2 times, and let's plug in e to the negative infinity, which is really close to 0, minus e to the 0, which is 1, which gives me negative 1/2 plus 1/2, which is 0. So this integral from negative infinity to infinity of this function is 0. I'll slide in a quick little graph here. It's not a perfect graph, but it's going to look something like this. And the reason the integral is 0 is because I have a negative part and a positive part that will cancel out. But now let's look at a different type, where we have an improper integral that integrates up against an asymptote. So consider my function y equals 1 over x squared. And let's integrate from 0 to 1. Now x never really equals 0, can't equal 0. So we have to do the technicality again, but it's a little bit of a different technicality. I'll choose a. And we have to do the limit as a goes to 0, but very specifically as we're going to 0 from the positive side. So that's a technicality that we need to use when we're doing an improper integral that goes up against an asymptote. We will continue and evaluate this. Doing our limit as a goes to 0 from the positive side. Plugging in our top limit. So we get negative 1 over 1 minus negative 1 over, and I will put this in. You might want to ask your professor. Sometimes they say, hey, you can't write it. I like to write it so I can see it. But it's 0 from the positive side, which gives me negative 1 plus, right, plus 1 over 0 from the positive side, which is infinity. So it doesn't really equal, but I'll put equal in quotations. And notice that this integral diverges. We'll look at one more example. It's a little bit of a tricky one. I just want you to be aware of something like this. So let's consider the function y equals 1 over x minus 2 quantity squared, which is like 1 over x squared but shifted to the right 2. And let's say I want to integrate from 1 to 3. Here's what's tricky about a problem like this. You can do the antiderivative, plug in 3 minus plug in 1, get an answer, but you have to recognize that there is a vertical asymptote in the middle of our interval. So we must split the integral at x equals 2 in the following fashion. So I'm going to go towards 2 from the smaller than side, from the left side. So I do something like limit as a goes to 2 from the less than side. And then the integral from 1 to a of my function. Plus, I'm also going to integrate from 2 to 3, but I'm approaching 2 from the greater than side this time. So I'll do the limit as b goes to 2 from the greater than side and replace that 2 with b. Giving us this. This is the way you need to approach a problem that is an asymptote in the middle. Why it's tricky is because if you don't recognize there's an asymptote, you'll get a finite value. And we'll see that we don't actually get a finite value in this problem. So if I continue on, limit as a goes to 2 from the less than side, I'll find the antiderivative and do from 1 to a. Now, I'm not even going to do this side. We'll see why in just a second. Let's just do this left-hand side. So if I plug in, I get negative 1 over Now if I'm plugging a number that's slightly less than 2 into this, I'll get really close to 0, but from the negative side. And then minus 1 over 1 minus 2. Now what matters is this first piece. Notice that this goes to infinity. Plus 1, but the plus 1 doesn't matter. Because I have a negative 1 over 0 from the negative side, so I get positive infinity, which of course matches my graph up here. I get a positive value. Now the fact that one part of this was infinite, that is, this first part of the integral went to infinity, I don't even need to worry about the second part. Now you might ask, what if the second part went to negative infinity? It doesn't, but in other problems it might. What if it did do that? Doesn't infinity minus infinity equal 0? And the answer is maybe, but rarely, and it doesn't matter. So if I'm doing a problem like this, where I have two separate integrals and one part goes to infinity, I automatically know that the entire integral diverges.